just try to pretend that you're not stoked to prove that the derivative of tangent x is secant squared x. Okay, so what's the point of this video? The point of this video is to go over all of the trig functions, not just sine and cosine and their derivatives. Now that you know the quotient rule, there's a way to then show what the derivative of tangent is, cotangent, secant, and cosecant are. So we're going to find those derivatives. We're just going to prove one of them. So prove that the derivative with respect to x of tangent of x is secant squared x. Okay, so to do that, we're literally going to take the derivative of this, but we're going to write it as sine x over cosine x since we know the derivatives of each of those functions. Oh, that is a quotient. So we'll use the quotient rule. Okay, well that'll be bottom or low d high. The derivative of sine is cosine. Very nice. Minus high, which is sine of x, not high like hello, but high, the upper value, times the derivative of low, which is minus sine x. The derivative of cosine is minus sine x. Ah, if you don't already see, it's pretty cool. All over the bottom squared, or square the bottom and away we go. So that'd be cosine x squared. Okay, how is that secant squared? Let's do a little simplifying. Cosine times cosine is cosine squared x, minus that minus sine squared x could be plus sine squared x. Nice. All over cosine squared x. Right? Cosine of x squared can also be written like this. Just shorthand notation, that's all. Cosine squared plus sine squared is 1. That is that golden rule of trig, right? The Pythagorean identity. 1 over cosine squared x. Well, 1 over cosine is secant. So this is really secant squared x. Oh, yeah. Beautiful. Do you need to know how to prove this? Likely not. I mean, some AB and BC teachers might ask you to, but most teachers won't. I want you to know, though, where the following formulas are about to come from and why this is lumped in with quotient rule. The quotients that are involved in the 4 remaining trig functions we don't know the derivative of, well, I guess 3 because we just found tan, are in these 4 functions. Tangent is sine over cosine. There's a quotient. Cotangent is cosine over sine, quotient rule. Secant is 1 over cosine, quotient rule. And cosecant is 1 over sine, the quotient rule. So you need the quotient rule to prove all of these. Sine and cosine we already know. So we're going to end this video just making sure that you know your derivatives of all these functions, and we'll practice them in the exercises. So the derivative of sine we already know is the cosine of x. Nice. The derivative of cosine is minus sine of x. The derivative of tangent of x is going to be, as we just saw, secant squared of x. Derivative of cotangent, a lot like that last one, but minus cosecant squared of x. The derivative of secant x, secant x times tangent x. Of course, yeah, that was my first guess too when I first learned it, right? Weird. The derivative of cosecant x is minus cosecant x, cotangent x. I'm going to come real close to the camera here. Memorize these. Memorize them. If you do not, you are going to be in for worlds of pain later in your calculus studies. So get a flashcard. You're standing in line, you know, for something, or you're waiting for somebody, or you're just bored. Throw out those flashcards for like 30 seconds. Know them. And notice these patterns. Once you know the derivative of sine and cosine, which we've had down for a little bit, notice that there's patterns here. Tangent is going to go with secant squared. Cotangent is basically the opposite of that. Co is in there. Anything with a co has a negative as well. So cotangent's just like tangent, but cosecant squared, co. Secant is secant x tangent x. Cosecant is almost the same. Cosecant, cotangent with the negative. So anything with a co has a negative, and co. Just a couple things to notice. It comes from the quotient rule. That's it. Memorize them. Short video. You got this. We'll practice more in the exercises. Peace.